Good day, everybody. Good morning, good afternoon, wherever you are. Good evening. সুপ্রভাত, সুসন্ধ্যা, শুভ দিন। আশা করি আপনারা সকলে ভালো আছেন। আজকে আমরা পি ভ্যালু নিয়ে কথা বলবো। আসসালামু আলাইকুম, নমস্কার। আমি তাহলে শুরু করছি, ইংরেজিতে বলছি, অ্যান্ড পরে আমি বাংলায় আবার বলবো। তো লেটস গেট স্টার্টেড। লেট মি শেয়ার মাই স্ক্রিন উইথ ইউ। So today we want to discuss about p-value. Do you always feel lost about p-value? Do you feel not knowing what's happening when they mention about p-value? Well, today I will break down what p-value exactly means. Are you left wondering how will I apply p-value to my data analysis? Well, I'll try to explain it in easy terms how to apply p-value to your data analysis. So you have to remember P stands for probability value. So it's probability value of a number. Okay. So the question is, what is the number? So let's talk about hypothesis testing a bit. So, suppose you want to find out what is the mean height of all the students at your campus. What is the average height of all the students at your campus? You have no idea about that. You have some rough idea, but you do not know exactly whether your educated guess is true or not. And you cannot reach all the students because it is time consuming, and you do not have the resource to keep asking every student in the campus what is their height. So instead of contacting all the students, you will work with most probably a simple random sample of say size 30, which you select from that population. So you ask each of those 30 students, what is your height? Okay, so you have 30 figures for heights. You add those numbers, we will work in inches. So you have 30 values of heights in inches, add all the 30 numbers, and then divide by 30. You get a sample mean age. Suppose, so our goal is to make an educated guess about the mean height of the population of students. Approach work with a simple random sample of size 30 from this population. Suppose the sample mean height x bar is equal to, say, 65 inches. That's like 5 feet 5 inches. Now, from this sample mean height of 65 inches, you can make an educated guess. So we are going to make an educated guess of population mean age, I mean mean height, I should say. Mean height, mu, that is mu, that's population mean. Population mean height, mean height of, let me erase that and take care of it. Nope. Oh, we have to work with this. So I'll write it clearly. Sharing the screen. Oops. So population. So I have to, let's move this. Let's move this out over here. Okay. Uh, So population mean height is given by mu, I said. So it's a population mean height. So we have to make an educated guess about the population mean height, which we guess, say, as 62 inches. So our status quo or null hypothesis, H sub 0, this is your null hypothesis or status quo. Is mu population mean height equal to 62. So this is your null hypothesis status quo. And the opposite, the alternate hypothesis, H sub A, alternate hypothesis, okay, sometimes also called the test hypothesis, because you got the sample mean height as 65 inches, your alternate hypothesis could be mu population mean height greater than 62. So you are going to check whether the sample data provide enough evidence to support the alternate or not. Okay. So suppose we know sigma, the standard deviation in population height. Standard deviation. You wonder what is standard deviation? Standard deviation is an average variation from the mean. Standard deviation in heights is equal to 3 inches. Okay. So we are going to compare the sample mean with the hypothesized value in the null hypothesis. This is sometimes written as mu sub 0. This 0 goes with null hypothesis H sub 0. Mu sub 0 is the value in the null hypothesis. So again, this is the value in the null hypothesis, value in H sub 0. Okay. So let's move this up a little bit. So let's compare the sample mean, which is 65, to the value in the null hypothesis, which is 65, and the value in the null hypothesis is 62, is equal to 3. Now, is this difference large enough for us to reject the null hypothesis and support the alternate? Okay. So question is the difference between the sample mean, between the sample mean and the value in the null hypothesis, value in the null hypothesis large enough so that we can reject H0 and support HA. Remember, the null hypothesis in hypothesis testing is like the defendant in a jury-based trial system. So at the start of the trial, the defendant is innocent. And then we look for evidence presented by lawyers from both sides, which will either support the alternate or will not support the alternate. So in the same way, we are looking for evidence from the sample data we have. So what we basically do is we calculate a standard normal score, which if you remember is called Z, for the sample mean X bar. Now if you remember the formula for Z, formula for Z, for standard normal, Z is equal to X, where X is any value in the distribution minus the mean of the population divided by standard deviation of the distribution. So mu is the mean population mean, and sigma is your population standard deviation. Population standard deviation. Population standard deviation. Okay. Now let me look one thing quickly. If I put this, and yeah. Okay. So we have to calculate the z-score, the standard normal score, z-score for x bar sample mean. Remember, x bar is a sample mean. Z will be equal to x bar will be compared to the value in the null hypothesis, but then we are going to divide not just by sigma, but by the standard deviation of the sampling distribution of x bar, which is sigma divided by square root of n, where sigma divided by square root of n is the standard deviation of the sampling distribution of x bar. Distribution of x bar. We could not have divided it just by sigma because we are comparing the sample mean to the value in the null hypothesis x bar, how far it is from mu 0. Then to calculate the normal score or z-score, we have to divide by the standard deviation of the sampling distribution of x bar, or probability distribution of x bar, which is sigma divided by square root of n. So let's calculate. Let's move this up a little bit, and we will calculate. Maybe we'll change the color of the ink too. So what color will look good now? Let's use this color. Okay. So, so sigma divided by square root n. We initially discussed that the standard deviation of heights is 3 inches and divided by square root of my sample size is 30. So I'll use my TI-84 calculator. I will do 3 divided by second button on the top left, and then x square will get me the square root in the denominator. Inside that, I will have a sample size of 30. So let's do that. So sigma divided by square root of n, which is the standard deviation of sampling distribution of x, is 3, which is the population standard deviation in heights, divided by second x square gives me the square root. Inside the square root, I type 30, and the answer is 0.5477. This is the standard deviation, sometimes also called standard error, of the sampling distribution. Now we are ready to calculate the z-score. So z-score for x bar is equal to, just let's make sure we have the x bar. X bar is 65. Is the formula is, so if I put, is x bar minus mu 0 divided by sigma divided by square root of n. So my x bar came out as 65. My mu 0 is 62, value in the null hypothesis. Let me make sure that is correct. So yes, value in the, yes, 62. So 65 minus 62 divided by standard deviation of the sampling distribution, which is 0.5477. So this will be 65 minus 62 is 3 divided by 0.5477. Now 3 divided by 0.5477 is equal to 5.477, is equal to 5.477. Let me erase this bit. So let's create some space. What does it mean? That means the sample mean of 65 is located approximately 5.48 times standard error times standard error above the value in the null hypothesis. In the null hypothesis. Now we will find what is the probability of that happening, assuming the null hypothesis to be true. So the goal now is to find out. Goal is to find out What is the probability? What is the probability or p value? Here comes the p value or p value. Okay, of the test statistic of z. Z is also called test statistic. Z is also called test statistic. Means a characteristic of the sample. This is the z score for x bar to be as high, at least as high as what we have calculated, which is 5.477. So, let me draw you a picture of the standard normal curve and you'll see the picture. So, let's start here. This is on the horizontal axis, you have z on the horizontal axis. At the center, z is equal to 0. So you have positive values of z on the right of 0, negative values on the left of 0. And the standard normal curve looks like this, approximately. Okay. This is your, let me clarify this a little bit. So going back, should be over here. Okay. So this is your z is 0. This is your 0 on the horizontal axis. And the peak is where the mean is 0 for this. This is the standard. This is the standard normal curve. Normal curve or probability distribution of z. Probability distribution of z. Of z. Or sometimes called the probability density curve. So for this curve, the center is mu is equal to 0 and sigma is equal to 1. Like I said, from the right of the mean at the center 0, you have positive. So you have gotten, for us, the test statistic or the z-score for x bar came out very high, somewhere over here, 5.477. It's way in the right tail. Okay, right tail. So right tail of the standard normal curve. So this is the standard normal curve or z curve or probability distribution. And our calculated test statistic z score is 5.477. So p value, so if I move it up a little bit, also I will change the color of the ink a little bit. Maybe I'll make it blue. Okay. So p value is the p-value is the probability of obtaining a test statistic or z-score. Remember, the test statistic is a characteristic of the sample. Test statistic or z-score at least as high as what we have obtained, which is 5.477, what we have gotten. So this shaded area on the right tail, this is your p-value. So this is your p-value or probability value. So probability value. So p-value is the probability of obtaining. So remember our null hypothesis was mu equal to 62 and the alternate hypothesis was mu greater than 62. Okay. So this is the two slanted lines indicating greater than, the meet at an edge pointing to the right. This is a, oops, sorry. So let's take care of it. So this is a right tail test. So let me go back here and erase this. Okay. So in this case, the p-value is the probability value or area under the standard normal curve, under the standard normal curve, under the standard normal curve to the right of the test statistic, to the right of the test statistic or calculated C. So how do I find that? Use TI-84. We can use TI-84 to find that, to find the area. So let me create some more space and also reduce this a little bit. So, oops, again, I have to take care of this. And standard normal curve. So let me correct that. What I have erased the right. So in your TI-84, we can press the second key and then the verse key. And then number 2, which is normal CDF. My lower is where I'm starting my calculation from, which is, remember, I have to find the area to the right of 5.477. So the lower is 5.477. Upper is 1E99. E stands for exponent, which is 1, and then second comma will give you the E for exponent, means 10 to the power of 99. 1 followed by 99 zeros. Leave the mean at 0 because this is the standard normal curve. Like I mentioned, for a standard normal curve, sigma is 0 and mu is 1. So, and then we will paste, we will enter and enter. So let's see what is the area. So p-value then becomes, okay, oops, p-value. So second verse 2 is normal CDF. Lower is, I'm starting my calculation from 5.477. My upper is a very large number on the right, which is 1. Then second and comma gives me the E99. Mean is 0. Standard deviation is 1. Why? You ask, because it's a standard normal curve whose mean is 0. Standard deviation is 1. Then I go down to paste and hit enter and enter twice. And look at the p-value. Do not get surprised at p-value being greater than 1. There is something hiding at the end. It is 2.168, then E minus 8, which means p-value is 0.0000000. Okay, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. And then 2, 1, 6, 8. Now, for all practical purpose, this p-value is 0. So you find the p-value, the probability of obtaining a test statistic at the minimum as extreme as what we have obtained. okay, and it came out at 0. What do you do with that? What is the meaning of that? That's a great question to ask. I appreciate that you're asking that question. I go through all this calculation, find a p-value, then how do I make my decision? Okay, so let's talk about it. So the p-value is 0. The p-value is going to be compared with the, so let's select. So compare the p-value. Let's write it a little bit up here. Compare the p-value or probability value to level of significance, to the level of significance, which is given as alpha. Okay, this is read as alpha. Usually alpha, so usually alpha is equal to 0.05. You ask what is alpha? What is significance? Alpha is the maximum risk of rejecting H0 when it is true. That is the maximum risk we are taking in making a wrong decision, alpha value. Now, if I compare my p-value in this case, usually, as I said, alpha is 0.05. That means we take a 5% risk of rejecting H0 with rejecting H0 when it is true. Okay, so here P is equal to 0. So therefore, P is less than alpha. Okay, P is less than alpha. The rule of thumb is when P is less than alpha, decision is reject H0. Okay. Conclusion is at alpha equal to 0.05, there is enough evidence to support HA. To support HA. What was HA, you ask? It was mu is greater than 62. Okay. Think of the practical aspect of it. Your educated guess was mean in the null hypothesis equal to 62. And you collected a simple random sample from the population whose mean height was actually 65. Now, if the null hypothesis is true, which is mean equal to 62, then how come we got a sample whose mean is 65? That 65 is located 3 inches away from the value in the null hypothesis. That distance is too large. Or in other words, the sample with a mean of 65 cannot come from a population whose mean is 62. Remember, the null hypothesis is mean equal to 62. Since the mean of the sample is located far away from the value in the null hypothesis, which is 62, therefore, our educated guess is wrong, and therefore we reject the null hypothesis and uh, support the alternate hypothesis at alpha equal to 0.05. Of course, we are taking a risk of 5 in 100 that we will reject H0 when it is true. And that is always the case. I mean, you'll have to take some risk. Okay, nothing is foolproof. I mean, there will be some amount of risk. But you got the point. The p-value gives you the probability of obtaining a test statistic or a value uh, that you got, okay, from your sample. What is the probability of obtaining a test statistic? That is the value in the sample, mean value in the sample was 65. How far it is located away from the value in the null hypothesis. So p-value will give you an indication of the probability of the sample mean to happen to be 65 when your educated guess of the population mean is 62. That means, in other words, the p-value is so low, that means the sample with a mean of 65 will not come from a population with a mean of 62, or in other words, our null hypothesis is not correct. Therefore, we reject the null hypothesis and we support the alternate hypothesis. Again, going back to the jury-based trial system, this is like we have enough evidence to support the alternate, which is the defendant is not innocent. Therefore, we reject the null hypothesis, and the verdict of the trial or the decision is to reject the null and support the alternate, which is the defendant is not innocent. That is, in other words, the defendant is guilty because the evidence points towards it. Same idea over here. We look for the p-value, that is how far the sample mean is located away from the value in the null hypothesis. If that distance is too large, then the probability of that happening, the sample mean to happen as large as 65, is very small. Hence, we will reject the null hypothesis. The point is here, you see, p-value is a probability value of obtaining a test statistic, which is a characteristic of the sample that we. Why it is a characteristic? Basically, we are calculating a z-score for the x bar, for the sample mean. And that is too far away from the center. Okay, so it's not going to happen if the center is correct. So in other words, the center, the null hypothesis is incorrect. We reject the null and support the alternate. I stop here today. So I started by telling you that if you're always thinking, what does p-value mean? So p-value means the probability of obtaining a value as stated in the null hypothesis. If that probability is too small, if that p-value is too small, then we will reject the null hypothesis and support the alternate. Okay, I stop here today. If you have any question, please write me a note. Please give me a comment. Do you like my presentation? Do you want me to continue doing this kind of presentation? And where are you watching from? I'm always wondering, where are my students, or where are the people who are watching my video coming from? I'm always interested in that. So let me know that, and if you like this video, give me a thumbs up. যদি এই ভিডিওটা আপনাদের ভালো লাগে, একটা থামস আপ দেবেন, এবং কোথার থেকে আপনারা ভিডিওটা দেখছেন আমায় প্লিজ জানাবেন। আই এম কিন টু নো দ্যাট। ওকে, সো আমি আবার ফিরে আসবো কালকে ইনশাল্লাহ। I'll be back tomorrow talking about another problem. Thanks for watching. Take care. Have a nice day. See you next time. And please subscribe to my video by hitting the red subscribe button at the bottom right corner. And also, please do not forget to click on the notify button. In that case, you will be notified every time I upload a new video. Thanks. Take care. Have a nice day.